Okay, here we go. This is 11.2, and these are the B and C level problems. So this first problem, number 13, let's talk about this one. You have to find the area of a parallelogram with a 45-degree angle and sides 6 and 10. Okay, so here's my parallelogram. And we're told that it has a 45-degree angle, so there it is. Okay, sides 6 and 10. We know that the area of a parallelogram is base times height. We know that the 10 is the base, but we don't have a height here. That's the problem. So what I need to do is I need to just look at this little triangle here on the end of this parallelogram. Okay, so I drop this perpendicular because that's the height that I'm trying to find. I know that this is 6. Now I'm given that this angle here is 45, and I recognize that the acute angles of any right triangle are complementary. So if this guy's 45, then this one is as well. And I know that all 45, 45, 90 triangles are similar, and that the ratio of sides of 45, 45, 90 triangles is, well, opposite the 45 is the side with the ratio of 1, 1, and then opposite the 90, radical 2. So I set up my scale factor. 6 is to radical 2 as h is to 1. I multiply the means, radical 2h equals the extremes, 6, and then I solve for h. So dividing both sides by radical 2, and then getting the rat out of the basement, I get 6 radical 2 over 2, which simplifies to 3 radical 2. Now I have the information that I need, that the area is 10 times 3 radical 2, which is 30 radical 2, of course, units squared, because I'm doing it right. Okay, so that's 13. 14, we have a rhombus. So here's the rhombus, and they tell us that the angle is 120. Now, one thing we know about rhombuses is that the diagonals each excuse me, bisect 2 angles. So this diagonal bisects 2 angles, this diagonal bisects 2 angles. I also know that the diagonals of a rhombus are perpendicular. So let's say this is our 120-degree angle right here. If this is 120 degrees, then each of these little guys is going to be 60 because it gets bisected. And if this is a triangle here, this little triangle, then this guy has to be 30 because the acute angles of a right triangle are complementary. We are also told that the rhombus has a side of 6. Okay, now I know that the area of a rhombus is 1/2 diagonal 1 times diagonal 2. The problem is, sorry about that, the problem is that I don't know the lengths of the diagonals. Okay, so, we'll call this guy diagonal 1 right here. All right, and then this guy we'll call diagonal 2, this vertical diagonal. That we're going to call diagonal 2. All right, so let's look at this triangle here and see what we have. We have 30, 60, 90, and this side length is 6. It is similar to all other 30, 60, 90 triangles with sides ratio 1, radical 3, 2. Okay, so we need the scale factor. 6 to 2 is equal to, this is the, I'm trying to find this dimension right here. I'll call this x. That's the same as this. All right, so 6 to 2 is equal to x over radical 3. Scale factor, the sides. And also, 6 to 2 is equal to, call this guy y here, y to 1. All right, so, you guys know how to do these proportions here. So I can just jump straight to the fact that x is equal to 3 radical 3, and that y is equal to 3. Okay, so if y is equal to 3, this entire dimension, this piece right here is 3, but also this piece is 3. So this entire thing is 6 units long. And if this x is 3 radical 3, then this entire dimension, d2, is 6 radical 3. Now we have the information that we need to finish this problem. So, diagonal 1 is 6, and diagonal 2 is 6 radical 3. All right, and I'm going to cancel. Remember, one numerator, one denominator. And so I get, this is a 3 here. 3 times 6 is 18 radical 3, and this is units squared, whatever they happen to be. All right, so there's my answer. Delightful. There's that answer. Okay, looking at 21 now. 21 is kind of a fun problem. You have to remember about SOHCAHTOA, our favorite. Okay, so for 21, you need to use a calculator or the trigonometry table on page 311 to find the area of each figure to the nearest tenth. Okay, so here's the picture that they give you. This side length here is 10. Let's see if I can get that a little bit bigger, zoomed in there. Zoom, zoom, zoom. Okay, nice and nicely focused. Okay, so this side length is 10. This we're going to call x. This angle, the reference angle here that they give us, is 20. All right, so relative to this angle here, this is my angle, this is the opposite side, and this is the adjacent side. So the trig function that deals with opposites and adjacents is tangent. So tangent of 20 is equal to opposite x over adjacent 10. So multiplying both sides by 10, I get that x is equal to 10 times the tangent of 20. So using a calculator, I get that x is equal to 3.64. Okay, and that is I've rounded to the nearest hundredth there. All right, now I know that the area of any triangle is base is 1/2 base times the height, or base times height over 2. So 10 being the base, the height being what we figured out, 3.64. 10 times 3.64 over 2 is 18.20. Of course, these don't have units, but really I should say units squared there. Okay, so that's that one. 23 is really similar. 23 is quite similar. So let's look at 23 here. Actually, this is 22. Okay, 22. Here we go. All right, 22, we have another setup here. Okay, I have this is x, this is y, this is 12, this is 54 degrees, this angle. And I need to find the area of this triangle. All right, so again, I'm going to use this as my this is my reference angle right here. And this side will always be my hypotenuse here. All right, so relative to my reference angle, this is the opposite side, and this is the hypotenuse. So the sine of 54 is equal to y over 12. That's opposite over hypotenuse. The cosine is equal to, this is the opposite side here, this is the adjacent side. The cosine of 54 is equal to the adjacent over the hypotenuse. Remember this? All right, and so delightfully, multiplying both sides by 12 here, I get that y is equal to 12 sine of 54. And I get that x is equal to 12 cos of 54. So just using the calculator, I can get, and don't forget to keep your calculator in degrees, folks, y is equal to 9.27 and x is equal to 7.05. Now, 9.71 is the base. The area of a triangle is equal to base 1/2 base times height. All right, 1/2 base times height. Base is 9.71. The height is 7.05 divided by 2. All right, there we go. There's our answer. Need to round to the nearest tenth. So the answer is 34.2 units squared. There's my answer. Delightful. Okay, the last problem, it looks hard, but it's really not. They give you this beautiful picture here. Okay, good to go. And what you have to find for this one is you have to find the area of ABC, that's the big triangle, and you have to find the area of AMB, that's this little one over to the left. they tell you in this problem that BC is 16. Okay, we have that. And they tell you that the height is 5. Now remember, the height is always makes a perpendicular pair with the base. So if the base is 16, the height here is this altitude from this vertex A down to the side BC. So we're going to call that 5. All right, that's nice. Okay, so find the area of A. The area of any triangle we know is base times height over 2. Don't forget that that's the same thing as 1/2 base times height. Okay, so I use these forms interchangeably. Okay, base times height over 2, 16. That's the base of the big guy, ABC, times the height, 5, divided by 2. That's, well, I'm going to just cancel the 2 with the 16 and get 8 times 5 is 40. This is units squared. And then because this M is a median, I know that this is a midpoint of this side length. So this is 8 and this is 8. Now, for finding the area of AMB, the base is 8, but what's the height? Well, believe it or not, the height is the same for this AMB as it is for ABC, because the way I get this height is I drop the perpendicular to the opposite side. Now this altitude falls outside this little triangle here, but that's okay, it's still an altitude. So base 8 times the height is 5 divided by 2. These guys cancel. 4 times 5 is 20 units squared. So I'm good to go there. Right, I believe that is it, folks. So sayonara. Bye-bye.